Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5 still on Newton's second law. It says the snowmobile pulls a sled down a snowy hill that has a constant incline of 25 degrees. The snowmobile exerts a force F on the sled. And then down here, it says the kinetic frictional force acting on the sled is 17.76 newtons. 5.1.1 says state Newton's second law of motion in words. So we say Newton's second law states that when a net force is exerted on an object of mass, the object will accelerate in the direction of the net force, where the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Right. Then 5.1.3 says, draw a labeled free body diagram to show all the forces acting on the sled. Right. Note that, acting on the sled. So the sled here, and then we are given 4 marks. So we know 4 marks, 4 forces. Then to start with this, we can just faintly draw the incline just to make sure that all our forces are perpendicular to the surface or parallel to the surface. So we have the normal force being perpendicular, and then down here we have the FG perpendicular, and then sliding down the incline will be our FG parallel, and then also sliding down the incline, that's our force F that is exerted by the snowmobile. And then up the incline, we have the kinetic frictional force, right? So the free body diagram that you should have is that one. And then how do they mark it for 4 marks? So remember, this is 1 mark because these are components of the gravitational force. And then we have 2, 3, and 4. So 4 marks like that. Now, 5.1.3 says calculate F, the force exerted by the snowmobile on the sled, if the sled accelerates at 5 meters per second squared down the hill. Right. So how do we calculate that? We obviously have to use our free body diagram for that. Now, choosing the direction, we can see down the slope here is our positive direction, since this whole system here is going down the slope. So this is the direction of motion. And then our negative direction will be up the slope. So using the Newton's second law, we will go F net is equals to MA. So let's indicate that this is 5.1.2. Now, we know that all the forces in the positive direction should add up, and then all the forces in the negative direction should subtract, like that. So it's F plus FG parallel minus the one in the negative direction. Then that's equals to mass times acceleration. We are to calculate the force here, but then remember FG parallel breaks down to FG to mg sine theta. So let's just break this down. This is mg sine theta minus Fk is equals to mass times acceleration. We do not have the force, but we do have the mass of the sled. We are told that it is 50 kg. So that's 50 multiplied by 9.8, and then sine 25 degrees minus, remember we are told that the kinetic frictional force acting on the sled is 17.76. Then we have 17.76 here. The mass again is 50, but multiplied by the acceleration of 5 meters per second square. Then let's multiply that. Punching all this here into our calculator, we have the force is plus 189.32 is equals to multiplying 50 times 5. That's 250. Then to calculate our force, we have to transpose this to this side. So that's 250 minus 189.32. Then our force is equals to 60.68 newtons, right? And then you have it like that for 4 marks, right? So let's proceed to 5.2 now. In 5.2, we are given two spheres A and B having masses of m and 8 kg respectively, are connected by a piece of light inextensible string. They are pulled vertically upward by a constant applied force P of magnitude 200 Newton. They say ignore the effect or the tension in the string connecting A and B is T. And then they say now ignore the effect of air resistance. Now below here, they say the net force acting on the 8 kg sphere is 40 Newtons. Then calculate the mass M of sphere A. Now to work with this, let's first draw the free body diagram representing all the forces acting on each sphere. So starting with sphere A, can say this is our sphere here. And then we know that we have the gravitational force acting downward. And then up there, we have force P. And then also down the slope, down here, we have the tension, right? And then that's for sphere A. But then for sphere B, the forces acting on sphere B are the tension, which is acting upward in reference to B, and then also the gravitational force like this. Now that we have the free body diagrams, let's try to calculate. We can see that we are given the information in sphere B. We have the mass of sphere B and then also the net force for sphere B. So it will be much easier to calculate the acceleration using sphere B, right? So let's indicate this is sphere B. Remember, we are to calculate the mass. So we know we are trying to calculate the acceleration here because we understand that if this is a system here joined by the same tension, then that means they have the same magnitude of tension and they also have the same magnitude of acceleration, right? So now we can use that fact here to say this is F net is equals to M times A. Our F net we are given that is 40, but our mass is 8 kg, then acceleration. Then if we divide both sides by 8, our acceleration is 5 meters per second square, right? Now we can use this acceleration to actually calculate this tension here because the tension here is the same. The tension experienced by sphere A is the same tension experienced by sphere B, right? So let's use that to calculate the tension. We can now break down our F net. This is F net is equals to MA. And then using sphere B, we understand that this here will be the positive direction, and down here we will have the negative direction. Why? Because this is being pulled vertically upwards. So if it's pulled vertically upward, we have our positive here and our negative down. So this is T minus Fg is equals to mass times acceleration. We are looking for the tension now. So we have Fg is mass times the gravitational acceleration, which is 8 multiplied by 9.8. And then here we have 8 multiplied by 5, right? Then this will give us T is equals to 8 multiplied by 5. That's equals to 40. Then if we say 8 multiplied by 9.8, it gives us 78.4. And then it's negative here, but if we transpose it, it becomes positive. So I hope you understand that. Then that's 118.4 newtons. So now we've found the magnitude of the tension. And what do we understand by this? If the tension here is 118.4 newtons, also the tension in sphere B must be 118.4 newtons. Because remember, in a system, the tension and acceleration is always the same, right? So now, let's then use this to find the mass in sphere A, right? So allow me to just erase this part here. Okay. And then let's calculate the mass in sphere A by saying F net is equals to MA. And then now looking at sphere A, this is the positive direction. Remember, it is still being pulled upward. And then all this down here will be in the negative direction. So that means my equation will be P minus Fg minus tension and is equals to mass times the acceleration. Now, P we are given, they said a constant applied force P of magnitude 200 Newton. So let's substitute 200 here. Then our FG is mass times the gravitational acceleration 9.8. Remember, we do not have the mass. That's what we are looking for. But we do have the tension. That's 118.4. And then our mass, again, we do not have it, but our acceleration is 5. Remember, we calculated the acceleration, and it is the same acceleration in a sphere A. Then this is 200 minus 9.8 m, and then minus 118.4 is equals to 5m. Now we can say 200 minus 118. So let's just leave this here. 200 minus 118.4. Then let's transpose the negative 9.8. That will be 5m plus 9.8m. Right. Then having to punch this into your calculator, you get a 81.6. And then adding this one here, that's 14.8m. Then let's divide both sides by 14.8. We divide both sides by 14.8, then our mass is now equal to, so let me write it here, so come here, then our mass will be equal to 5.51 kg. So sorry for the mess there, but then I hope you get all this, you can follow. And then that's how you were just supposed to solve that question, for a total of 6 marks, and then all this question for a total of 16 marks. So please press the thumbs up button if you have enjoyed the lesson and then you have also found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.